bioplastic made, like we say, from seaweed as its main ingredient. And our goal with this project is so we can reduce plastic pollutions and so we can encourage the use of sustainable alternatives like the one we are proposing. And now for the results, we have two graphs and a table. For the results, we decided to compare the conventional plastic or petroleum-based plastic and the seaweed bioplastic. The properties we decided to choose were tensile strength, flexibility, water absorption, biodegradation, thermal stability, and moisture resistance. I'd say the one we focus on more is biodegradation, and we have here the graph for biodegradation. This is the time each plastic takes, the conventional plastic being the blue one that only becomes microplastics and never fully decomposes. And the green one is the seaweed bioplastic that takes between 30 to 90 days to almost fully or fully decompose into a non-toxic substance like water or carbon dioxide. And we also have here the carbon dioxide emissions per kilogram of material that is created. For the rest of the properties, like we said, it's tensile strength that we decided to measure it in megapascal. And we can see that the seaweed is slightly weaker than the conventional plastic, but it's great still for like packaging, like food, or I don't know, things that weigh so little. For the flexibility, we can also see that another disadvantage is that seaweed bioplastic is not so flexible and not elastic unlike conventional plastic. And we can see in water absorption that the seaweed bioplastic is hydrophilic. What is hydrophilic? Hydrophilic is that seaweed plastic can easily absorb water, which is the opposite of conventional plastic that is hydrophobic. And we can also see its thermal stability is another disadvantage for the seaweed since it melts if it's over 130 degrees Celsius instead of the conventional plastic. And at final, the moisture resistance, we can see that the seaweed bioplastic can maintain its properties and perform well under moderate and high humidity conditions, unlike the conventional plastic that can only live under high conditions.
Here's why our STEM project is so important is because it's not just another alternative, but it stops the problem at its source. Our problem is basically the prototype that we will be demonstrating has a lot of parts. One of these is the drying mold, which is basically there will be a tray, and then we will be placing the seaweed inside, and then with a cover, we will make pressure so that it forms into a gel-like mixture. And then after this, you can see like over here, there's like a circle. This is for the airflow. That's the hole. And after it dries, then you can shape it over to like the bags and stuff.
For the problem raised, can robotics be applied as an area of improvement? And the answer is yes, robotics can help improve this project by automating seaweed harvesting and packaging production. This would make the process faster, more efficient, and easier to produce on a larger scale.
And now, did your mathematical results confirm or reject your hypothesis? And the answer is yes. The math demonstrated that our solution successfully reduced plastic by 10%. And the other is that what will be your conclusion about the mathematical results contributed to Cornfield's? The math confirmed our hypothesis, saying also that it reduces plastic by 10%. So that could be meaningful because it will be less plastic waste.
So finally, for our conclusions, for this project, I learned to work as a team and to find the bioplastic that we need for our research. We could investigate a lot of parts on it, and we learned the importance of finding a solution that
against plastic pollution because it has become a major issue over the years. And also I learned a lot about teamwork and responsibility.
In this project, I learned about seaweed, how can you make it a plastic, a biodegradable plastic that is a good alternative to plastic. And I discovered that mixing seaweed with glycerin and vinegar is possible to create a flexible plastic. This can lead to understand the importance of using natural resources to reduce pollution.
During this project, I learned a lot about plastic and about the impact of every of our actions have. Before this project, I used to think that our actions individually don't have any impact, but then I realized that every action has an impact on the environment, so why don't have a good impact on the world? I also learned the importance of properly functioning teamwork and how efficient it can be when done correctly and when everybody has an assigned work to do. And mostly, what I'm most grateful for that I learned was that I learned how to was that I became much more aware of my actions and how my actions treat the world that we live in.
I concluded from this STEM project that we work on team, we can do great, we can achieve great things, and that we have to take care of our planet with our actions and be conscious of our ambient. Because if we don't, we can lose it all.
Well, for my conclusion, the things that I learned is that teamwork makes it greater. With teamwork, we can focus more on promoting like these types of alternatives. That is what we want to do with STEM. I think STEM is like a great activity to do because it leads teenagers to give possible solutions to the future and to like being of our planet, because if we as teenagers don't take care of our environment right now, in the future we don't know how it will be like. We don't know if we will still be here or if the planet will even still be here.
Here's our radiography where we have all the resources and all the data we acquired.